So today we're going to cover part of Section 5's notes. We're only going to talk about permutations today. But before we do and get into the permutation, I'm going to teach you something called the fundamental counting principle. And you can use this to figure out a shortcut way to figure out how many different arrangements when you're given two different things and you want to make different arrangements of those items. And when there are m ways to do one thing and n ways to do another, then there's m times n ways of doing both. So let me give you a scenario here where we actually have numbers for m and n. So here it says, for example, you have 3 shirts to choose from and 4 pairs of pants. They want to know how many different outfits you can make using those 3 shirts and 4 pants. So in this particular problem, my m could be the number of shirts, my n could be the number of pants. You just multiply 3 times 4, and we can make 12 different outcomes or outfits using those 3 shirts and 4 pants. And this is called using the fundamental counting principle. Before this, what we would have had to have done is either do a tree diagram, or what you can do is maybe something that looks sort of like a spider web here. Let's say you have a yellow shirt, and I'll do this with like a S1. Let's say you have a green shirt, and let's say we have a red shirt, and we want to make different outfits. So we could say we have yellow pants, green pants, and white pants, and gray pants. So you could make a combination and you could say, well, I could put the yellow shirt with the yellow pants, or the yellow shirt with the green pants, with the white pants, and with the gray pants. So using my yellow shirt, I've got 4 different outfits I can make with the 4 different pairs of pants. Then you can go through and do the same thing with the green shirt. You could put it with the yellow pants, the green pants, the white pants, and the gray pants. So I got another 4 outfits. And then lastly, we could take the red shirt, put it with the yellow pants, green, white, and gray for another 4 outfits. And notice it's a total of 12. And I got that same answer by using my fundamental counting principle. So you don't need to draw it all out. Just take the number of objects you have from each one and then multiply them. Another example, let's say you're going to buy ice cream, and you can choose from 6 different flavors of ice cream and 3 different cones. So to find all the different arrangements of ice cream with a particular cone type is just 6 times 3, and there's 18 different arrangements that you can do with the 6 flavors of ice cream and 3 different cones. Now, you don't necessarily just have to have 2 things. Let's say you're going to buy a sandwich. And let's say with the sandwich types, we can choose from 2 different bread types. We can either get bread or we could get maybe a sub roll. And then on our sandwich, we can choose from 3 different types of meat. We could get ham, turkey, or roast beef. And then we also want to put cheese on our sub. And let's say there's 4 different cheese types. Maybe American cheese, Swiss cheese, provolone, or I don't know, Munster cheese. So let's say there's 4 cheeses. So if they wanted to find how many different types of sandwich combinations you could make, you're going to multiply 2 times 3 times 4, and you could make 24 different sandwich combinations by choosing 1 bread, 1 meat, and 1 cheese. So this is using the fundamental counting principle. That is followed by an exclamation point. That is called a factorial. So it's going to have a number, and then it'll have an exclamation point behind it. So for example, I could put the number 3 with an exclamation point behind it. Now, the way that our book teaches it is it tells you to start at that number and do like a countdown, and then do 3, 2, 1, and then you multiply those 3 numbers and you get 6. Now, other textbooks tell you to count up. Either way, you're still getting the same answer. So it's a matter of a repeated multiplication. Now, if you ever see something with n factorial, that just means that you start at that number, and if you're going to count backwards, you subtract 1 each time. Now, one thing to memorize is that 0 factorial equals 1. Also, 1 factorial also equals 1. So just memorize this. This is just a rule that you memorize, that 0 factorial equals 1. Now, I just did the 3 factorial. Let's say it was 5 factorial. We start here, 5 times 4 times 3 times 2 times 1. Or if you'd rather count up, 1, 2, 3, 4, 5. Either way, you're multiplying all of those numbers, and your answer here would be 120. So let's go ahead and now see the definition of a permutation. We're going to be using factorials in the formula for a permutation. You see a number, and all a permutation is it's an arrangement of objects in which order is important. So for example, let's say I have 3 letters, A, B, and C, and I want to know how many different arrangements I could make choosing 2 letters at a time where order is important. So for example, I could choose A and B together. I could choose B and C together. Or I could also choose A with C. So let me go ahead and do this in a color that'll show up. Okay, so these are so far. And now, if order is important, then I also have to list B with A. Even though I listed A with B, B with A, when order is important, where I'm selecting 1 letter at a time, this would count. Then C with B would count. And then also C with A would count. So this would be 6 different arrangements choosing 2 letters at a time. Now, in tomorrow's lesson, we're going to find how many combinations there are where order isn't important. And when I see this tomorrow, I would not include these doubles. So there's only 3 combinations, but there's 6 permutations because the order would be important.
Miss Corey.
So it says the number of permutations of n objects is given by, and this is the notation, it's a P with an N and an N, and when that occurs, when that value is the same, it's just n factorial. So an example of this could be, let's say I have 5 trophies, and I want to arrange those 5 trophies on a shelf. So I want to put them on a shelf. I want to know how many different arrangements I can make with those 5 trophies. So in this particular problem, when they don't give me a second number, my n value is 5. So I'm just going to be doing the permutation of choosing 5 things from 5 things, which is equivalent to 5 factorial. So 5 factorial is equivalent to 5 times 4 times 3 times 2 times 1. And there will be 120 different arrangements of those 5 trophies on the shelf. Now let's say instead I don't have a lot of shelf space, and from these 5 trophies, I only want to display 2 of them. So I have 5 trophies to choose from, but I only want to put 2 on my shelf. So in that case, we're going to use this new formula, and we're going to introduce another variable, which is R. So the n value is how many objects you have, and the R value is how many you're going to take at a time. So I'm going to be taking 2 at a time. So I'm going to be putting it into the formula. NR equals n factorial over n minus r factorial. So P and then 5 and 2. So I'm going to replace my variables. 5 factorial, 5 minus 2 factorial. I'm going to simplify the parentheses. And now I can't divide this, but what I need to do is expand it. So I'm going to expand 5 factorial. It becomes 5 times 4 times 3 times 2 times 1, all divided by 3 times 2 times 1. Now I'm going to go ahead and simplify. I can simplify. These become 1s. Anything divided by itself is 1. So there are now going to be 5 times 4, or 20 arrangements of choosing 2 trophies at a time to display. Now, if you don't want to write out 5 factorial, if you see what the bottom factorial already is, you could break down the 5 factorial and bring it down as far as the denominator and then just cancel. You can do that as well. Let's try some word problems now using this information. So example 1, it's got 2 different examples here. It says, in how many ways can you arrange the letters in the word mouse? Notice there is no, there's not 2 different numbers here. The first number that I'm going to come up with is counting how many letters are in the word mouse. And in the word mouse, there are 5 letters. So in order to find the ways that we'll do this, we're going to be just doing 5 factorial. So 5 factorial is 5 times 4 times 3 times 2 times 1. Because if you think about it, there were 5 letters to choose from for the first spot. Then after you place that letter, now we only have 4 letters to choose from, then 3, then 2, then 1. So there are 120 different ways that I can rearrange the letters in the word mouse. Doesn't necessarily have to spell a word. I'm just rearranging those letters. For the second part, now I'm going to only choose 3 letters out of the word orange. So the first number I need to figure out is how many letters are in the word orange. And there are 6 letters in the word orange, and that is my n value. My r value is how many letters I'm choosing at a time. The r value will always be less than the n value. So I'm going to plug it in. P, a 6, and then a 3. Remember, the formula we're using is going to be P n r and n factorial over n minus r factorial. And then we're going to plug in the numbers. When you're doing the homework tonight, even if you figure out where the buttons are, I want to see how you're plugging in the n and the r into the formula. So this is going to become 6 factorial over 6 minus 3 factorial, 6 factorial over 3 factorial. Now, I know 6 is divisible by 3, but you cannot divide numbers that have exclamation points. So I'm going to expand it out. This becomes 6 times 5 times 4 times 3. Now, if you want to stop here at the denominator factorial, the 3 factorials cancel. And now I'm just left with multiplying. 6 times 5 is 30 times 4 is 120 ways to choose 3 letters from the word orange and arrange them. Try the next one. If you don't figure out where the probability button is, where you just do the permutation, another way that you can do this, if you figure out where the exclamation point is on your calculator, you could also do this. You could do parentheses 6 factorial divided by parentheses 3 factorial, and it'll give you 120. However, I still want to see how you're plugging it into the formula. Let's try the next one. It says your band has written 12 songs and plans to record 9 of them for a CD. In how many ways can you arrange the songs on the CD? So again, we have 12 songs to choose from, and we want to record or choose 9 of them. So my setup is going to be P, my N value is 12, and my R value is 9. So I'm going to plug it in, 12 factorial over 12 minus 9, 12 factorial over 3 factorial. This one's going to be really large. So I'm going to expand out the 12, 12, 11, 10, 9, 8, 7, I'm going to switch to a darker color, 6, 5, 4. And again, if you want to go all the way down to 1, you can. If you'd rather just leave it as 3 factorial, you can, because remember the 3, 2, 1 is going to cancel. And now I'm left with multiplying. 12, 11, 10, 9, 8, 7, 6, 5, 4. And this is going to give me 79,833,600 ways to arrange the songs.
Why did you cross out 3, 2?
You could have also done, and again, you really need to do parentheses if you're going to do this. If you find the exclamation button. However, a lot of calculators have a probability button where you're just going to key in the original N and R value, and then it gives you the answer. But again, on the test and in the homework, I want to at least see this part of the formula. I want to see how you put it in, this part. Let's try the next one. So for example 3, now this is where it gets a little tricky because now we're bringing in probability. So for a town parade, you will ride on a float with your soccer team. There are 14 floats in the parade, and their order is chosen at random. Find the probability that your float is first and the float with the school chorus is second. So the steps in order to solve this, there's 3 of them. Step number 1 is to find the total number of outcomes of arranging those 14 floats. So we're going to find the total number of outcomes, and that'll be found by doing 14 and a 14, which is 14 factorial. I'm just going to leave it there for now. Then step 2 is going to be to find the favorable outcomes. So we're going to find the number of favorable, because remember, probability is favorable over total. So we're going to find the number of favorable outcomes given that the soccer team is first, and the school chorus is second. It's the second float. And the way that we're going to do that one is probability of 12 out of 12 because we've eliminated 2 of them. We've taken out the soccer team's float and the chorus, so that's 12 factorial. So now to find the probability, remember it's favorable over total, so the probability that the soccer is first and the chorus is the second float is going to be 12 factorial, favorable over total. Now, I'm going to go ahead and expand it. I'm not going to write all the numbers. I'm going to leave the 12 factorial. And then the bottom, I'm going to do 14 times 13 times 12. And then I stop there because it matches with the top. This becomes a 1. This becomes a 1. 14 times 13 is 182. So the probability that the soccer team is the first float and the chorus is the second float is 1 over 182. All right, so it says find the number of ways you can arrange all of the letters in the word boundary and then 3 of the letters of the word. So this is 2 different parts. So for all of the letters, I'm going to count how many letters are in the word boundary, and that's going to have 8. So I'm going to be doing 8 factorial for all of the letters, and that's going to give me 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. So if you're not able to find the factorial button on your calculator, you're just going to do the multiplication. It's easy enough. This gives you 40,320. Now choosing 3 letters at a time, that's going to be my n value will be 8. My r value would be 3. 8 factorial over 8 minus 3 factorial. 8 factorial over 5 factorial. And again, expand it. I'm only going to take the 8 down as far as the 5. So that way I can just cancel the 5s. And now I'm just left with multiplying 8 times 6, which is 56, times 6. And my final answer here is 336 different ways to rearrange 3 letters of the word boundary. Now, examples 2 and 3 here, all we're doing is plugging in the n and the r value. And you'll get a question this easy on the test. So as long as you know the formula, all you're doing is plugging in the numbers. So this becomes 6 factorial over 6 minus 3. 6 factorial, 6 minus 3 is 3. And again, expand it out. 6, 5, 4, 3 over 3. That cancels, and it's 120. For number 3, it's going to be 14 factorial over 14 minus 9. 14 factorial, 14 minus 9 is 5 factorial. So this one I'm going to expand all the way down to the 5. 13, 12, 11, 10, 9, 8, 7, 6. And then I'll stop at the 5 because I can cancel the denominator. And now I need to multiply all those numbers. And I get a really big number here. I get 726,485,760. And then for the last one, another probability. We first have to do it just like we did before with the floats. We need to find step number 1, find the total number of outcomes. And it says there are 8 students auditioning for the main role in the school play. The order of the student auditions is chosen at random. Find the probability that you were chosen first to audition and your friend Petra is chosen second. So the total, there's 8 people, so 8 factorial. For the favorable outcomes, I'm taking myself out of that 8 and my friend Petra, so that only leaves 6 people to arrange. So then the favorable would be you were first and Petra is second. So I'm going to, step 3 is to find the probability. And again, remember, probability is favorable over total. So the probability that you are first and Petra is second is going to be 6 factorial over 8 factorial I can go ahead and expand it. 8 times 7 times 6 factorial. The 6 factorials cancel. Don't forget that when you cancel this, a 1 is left there. So then 8 times 7 is left, so 1 over 56. So the probability that I'm going to audition first and then Petra second is 1 over 56. So that is it for the day 1 for permutations. Tomorrow I will finish the notes on combinations and then again learn how to use that formula.